Okay, how are you everybody who is watching this fantastic video? I'm very happy to have you today, and I would like to take this opportunity to welcome some physical students who are in this class and also some online students who are have a true love with electronics engineering. If it's the first time to meet me, my name is Olenjolai. I thank God who have given me a gift of teaching and a gift of electronics engineering. So I would like to invite you into one of the modules that we are teaching our physical students at the Dar es Salaam Institute of Technology in departments of Electronics and Telecommunication Engineering, and the name of the modules is called the Electronics Communication Laboratory. This is one of the modules we are providing in telecommunication section or in the section of telecommunication engineering, and I'm very glad I have some information concerning about technical information that I would like to deliver to you today. Then this is workshop 2. We have done workshop 0. We have done workshop 1. In case you missed them, you can access those contents. They are already on your fingertips. Another thing which I want to tell you that these contents that we are providing are the contents which can help beginner and intermediate students who are studying in either of the following 6 fields, who are studying diploma and diploma or bachelor in electronics engineering, diploma and bachelor in telecommunication engineering, diploma or bachelor in computer engineering, diploma or bachelor in electrical engineering, diploma or bachelor in mechatronics engineering, diploma or bachelor in biomedical engineering. So I want to tell you that all of those fields are the electronics related fields. So these contents are very important. Whether you are a student in those departments or in those fields, these contents will help you. But again, these contents are good to prepare students who want to study about those fields, even if you have graduated in your O-level education or in your A-level education. The curriculum you are using is the curriculum of Dar es Salaam Institute of Technology. However, that we can go beyond of the what curriculum has stated to us. So, what are the requirements for this course? We are just having 3 phases: theory, simulation, practical. So for the theory, we just need your mind, your fresh mind, and your active participation. In case you have a question, don't hesitate to ask it in the comment section. And then, because I'm ready to teach you about what I've prepared. However, that I don't know everything about what I've written there, but I'm ready to teach you and to take you to the next step. So let me acknowledge some physical students. How are you, students? How are you, students? How are you, students? Okay, so the module names, as I said, it is electronics. Say Electronics Communication Laboratory. Say Electronics Communication Laboratory. Okay, then we are in chapter 1, General Introduction for Electronics Communication Laboratory. It is chapter actual gives you some skills that you need for you to define and even to interpret different skills and the knowledge that you have to achieve in electronics, or we call it in Electronics Communication Laboratory. So we are in workshop 2, that's called the data sheets in electronics engineering, or data sheets of electronics. I think that, yes, let me change this one. Data sheet of electronics components. Electronics components. Class A data sheets of electronics components. Say data sheet of electronics components. If you refer workshop 1, this was a homework 1. I left it to you. I believe you have worked on it. And I believe you presented your information in 5 languages of what? Of engineering. So maybe you have a lot, but let us verify what you have found and what I have found. So before we move on, let me just see, okay, the quick review, actual that, I think that, let me just have a short quick review of the previous workshop. A special workshop. Let me talk a little bit about that workshop what? Workshop 01. It has been titled as related tasks in what? In electronics communication laboratory. So we learned that every sub-enabling outcomes has its related tasks according to the DIT curriculum, right? How many sub-enabling outcomes do you have for this module? 5 sub-enabling outcomes. In the first sub-enabling outcomes, where actually that we have to design, or we have to teach, or we have to use the knowledge of electronics and telecommunication, knowledge and skills of electronics and telecommunication engineering is actual to design analog and digital circuits, right? So that concept has been broken into mainly 2 related tasks. So in analog circuits that we'll be using, or analysts, we call the analog communication circuits. So I've presented to you that you may either learn how to design amplifier, you may either learn how to design oscillator, you might also learn how to design filters, and I told you that these are not the power supply filters, but these we call them communication filters, okay? Then you might learn to design what? A differentiator, yes. Physical students, they have forgotten. Differentiator, also you might learn this concept by using or by designing integrator. So either of those analog circuits or communication circuits, or you may learn all of them. Okay? So it depends on your seriousness. Then, in constructing digital communication circuits, because these are the digital communication circuits, digital electronics communication circuits. So we say that you may learn how to design encoder, say encoder. You may learn how to design half adder, say half adder. You may learn how to design full adder, say full adder. You may learn how to design multiplexer, we call them MUXI. You may learn how to design the multiplexer, we call them the MUXI. You may learn how to design counters. You may learn how to design what? A decoder. This is not all, but these are just the parts of them. And then the next sub-enabling outcomes was actual training us about the skills to choose the measuring instruments and how to use them. These modules can give you the skills to choose the testing points and how to use the measuring instrument to measure the parameters there. Are we together? So that's what we discussed in previous workshop. Thank you for the quick review. We discussed more than that. In case you missed the workshop 1, it's already in air in our official YouTube channel, which right now we thank God that there are 390 students who have registered themselves and they receive contents every week. So, today we are discussing about datasheet. Class, say datasheets. Again, say datasheets. Say datasheets of electronics components. Real. That's the voice of all the 50 students in this class. Say datasheet. Again. Again. Datasheets of electronics components. So until I please you, that's the moment when you speak, you pronounce the terminology loudly. So the fundamental question that you have to learn this is the new terminology along along your journey of learning. What is datasheet? What is datasheet of electronics components? What is the meaning of datasheet of electronics components? So there's the different ways that to define that terminology. But I found one which is actual, has a lot of information for the lovers of DC stuff. So firstly, before we write the definition, datasheet, simply this we say that it's a manufacturer's mind of electronics components. Say it. Check your neighbor. While you are saying it's the manufacturer mind of electronics component. Class, be powerful and be energetic. Say it's the manufacturer's mind of electronics component. Okay, I think today maybe you have some problems on speaking. So let me ignore it and let us move. So, after I gave you that shortest sentence, let us get into the long sentence. A data sheet, or sometimes we call it, or we write in this way, data sheet as one word, or we write in this way as spec sheet. Sometimes we call it a spec sheet. Simply say that is a document. Is a document that summarizes the performance and the other characteristics and the other characteristics of a product or other characteristics of a component or other characteristics of a machine. So you say that, open bracket, example, electronics component. So this is the simple definition of the word datasheet. We may call it datasheet are the two words or three words. Because the first one we call it an article R, then data, then sheet. Or we may call it data sheet as a single word, or we may call it spec sheet. So what does it mean? A data sheet or spec sheet is a document that summarizes the performance and the other characteristics of a product or a component or a machine. Example, electronics components. Are we together? Are we together? Are we together? So these definitions actually give the evidence of what I've told in advance. That this is manufacturer's mind about the electronics components which he or which his industry has manufactured. So every electronics component has its data sheet. Beginning from resistor, which it is 2 terminal, up to the microprocessor, which sometimes can have more than 200 pins. So there is no any electronics components which does not have a data sheet. Because without data sheet, we may abuse it, or we may use it, and we may destroy it. So if you know, you say that I know resistor, and you've never read any of the data sheet about resistor, I want to tell you that you still know nothing about resistor. If you say, I know transistor, and they've never read any data sheet about transistor, I want to tell you that you are still poor in knowledge of transistors. Because you just took a transistor, possibly you saw a certain schematic circuit, then you build it according to this, but you don't know the boundaries. You don't know its capability. You don't know its precaution. So this is the manufacturer's mind that tell us or give us the summary of the performance. What the performance of that electronics component. And then what are the characteristics? What are the characteristics of what? Of that electronics components. And when you say about characteristics, we don't mean that characteristics of living organism. No, 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 no. We mean about technical characteristics. Are we together? Are we together? Okay. So I don't know whether in your report you found this definition or the other one. You can correct yourself. Then, note the following points before we continue. Number one. Typically, a data sheet is created by the manufacturer and begins with, all the data should begin with an introductory page. An introductory page describing the rest of the document. Describing the rest of the document, followed by listing of followed by listing of specific characteristics. Specific characteristics with further information. Data sheet, class A data sheet. Even if you forget everything I told you about, just remember, today I've been introducing about data sheet. Data sheet explain exactly what a component does and how. What a component does and how to use it. Aha. So data sheet, it can help me to do the following things. Data sheet explain exactly what a component does and how to use it. So you wanted to learn about what a resistor does, what a diode does, what is silicon controlled rectifier diode does, what is bipolar junction transistor does, what is BC 547 transistor does, what is actual MOSFET transistor does, what is 55 timer does. You have to find its data sheet. But again, once you know that what it can does, what it can do, then the next question, how can I use it? So you find a lot of information about how you can use it. Are we together? Class, are we together? Yeah. I have physical students, more than 50, but I don't know what happened. They are completely unhappy. I'm trying my level best to convince them to be happy like me. Because to learn electronics, it's one of the source of happiness. Tell your neighbor, learning electronics is one of the source of happiness. You see, even your neighbor is unhappy, and you yourself is unhappy, So simply we say the equation is balanced. So he said that unfortunately, number 3, unfortunately, these documents, are usual. Written. So this is the challenge now. Are usually written by engineers, by electronics technicians, and the electronics engineers. Professional electronics, written by professional electronics technician and the professional electronics engineers. For other engineers, for other electronics engineers, or for other electronics students, for other electronics engineers or students. And due to that, they can be often difficult. They can often be difficult to read. Especially by beginners engineers. So who use in those, we say that the data sheets are being written by manufacturers. So we say that data sheets are being written by what? Say manufacturers. So those manufacturers are professional electronics engineers and also are professional electronics technicians. So they write this data sheet more technically. So due to that, data sheets are not easy to be read, especially for electronics engineers. And that's why that I have to teach you. Because I will tell you that, okay, today we are using, let's say, HT12E encoder. That's what you want to learn. Then you don't know how to read this data sheet. Till be lying. I can teach you, but the secret I still have in my mind. So because that, unfortunately, these documents are usually written by professional engineers or electronics technicians and engineers for the other electronics engineers or students like you, and due to that, they can often be difficult to read and understand them. They can be difficult to read. When you say read, simply they can be difficult. In other words, they can be difficult to understand them. To understand them. Why? Because you lack some technical skills on electronics. Simple like that. So this is the fundamental skill every technical student has to know. Are we together? In a world of electronics, we have millions of electronics components. And I told you each of them has a data sheet. But the third point to note. The first point to note, that is number 4. Nevertheless of what? They are difficult to read. Nevertheless, data sheets are still the best place are still the best place to find the details you need. Find the details you need to design or you need to implement an electronic circuit. An electronic circuit. An electronic circuit. So in case you want to start design or implementing a particular circuit, there's no way out. You have to read the data sheet. You have to read and understand the data sheet. So are still the best place to find the details you need to design or implement an electronic circuit. An electronic circuit. Say best place. Say best place. Okay. So we don't have an excuse to learn it. Students, do you have any questions up to that point concerning about what we have discussed? In case you have any question, please ask it. Huh? Masa, do you have a question? No. Nema, do you have a question? Shukuru, do you have a question? So Shukuru does not have. Omolo? No. Robert? No question. Mikidadi? It's clear, eh? Okay. Wait, my questions in the exam. Because you say in the class you don't have question. Good. So then, let us now get into too much details on OT, on learning how to read and understand data sheet. Are we together? Are we together? Are we together? Yes. I ask every student to take the right hand and put on your head. This way. Take your right hand and put on your head. And then say by faith, my God, help me to learn how to read data sheet and understand them. Amen. Okay, for myself, my God, help me to teach your students how to read and understand this technical information that's called the data sheet. Amen. So for me, I believe. I don't know you. If you believe, fine. If you don't believe, it's also fine. So the second part that you have to cover, main parts of data sheet. Data sheets, most data sheets have some common main parts. So main parts of data sheet of an electronics component. Main parts of data sheet or data sheets of electronics component. So those main parts, it depends. But we as electronics and telecommunication engineers, we agree to have at least the main parts, 7 main parts of the data sheet that every electronics technician and every electronics engineer must understand them. So when you read the data sheet, you have to pass through those 7 parts and you will understood the data sheet. However, that you may read data sheet once, you don't understand anything. Second time, but third time, if you are real serious, you could get some information. So a data sheet or a data sheet's contents. A data sheet's contents will vary widely. Will vary widely depending. Will vary widely depending on the type. On the type of electronics component. Depending on the type of electronics component. So he said that data sheet contents vary widely depending on the type of electronics component. Some of the electronics components, they have just one page of the data sheet. Some of the electronics components, they have more than 50 pages. Okay? 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 Yes, I have students here who don't know how to say yes or no. Most electronics data sheets, usual have some common section or some common main parts. So the following are the main, are the seven, the following are the seven main parts of the electronics data sheet. So the first C is called the first main part is called the summary of features and the functions. And functions of electronics component. Of electronics component. So class, if you like, but for the online students, I know that you like, you may say or you may read, say summary of features and functions of electronics component. Again, say summary of features and functions of electronics components. So the first main part that you have to learn is you have to learn the summary of features. Say features. Features. The AK of features is what? Characteristics or some features. So we say that summary of features and functions of electronics component. That's the first main part. The second main part, let me mention all the seven. So when I'm teaching, just to check about what you have found, because this was homework, and you did that homework for almost a week. So check, what did you find? Did you find what you are supposed to find, or you have just went on Google and find some articles and copy and paste? So analyze. Did you do that homework? You didn't do. You didn't do. Robert, did you do the homework? Oh, yeah. I have students here who don't like to do what? Homeworks. Wonderful. That is good. So way to learn or to master electronics by miracles. I have some students who are here who are waiting miracles. So pin out a list, or this part, we can call it pins, assignments. We don't mean assignment that maybe the individual assignments or maybe the group assignments. We don't mean about that. Pins, assignment, or pins, configuration, and the pins description. This is the second part. So in the first part, we learn features of, let's say, diode, and also it learns function of a diode. In the second part, we'll be learning about pin out list. Say pin out list. Pin out list. So pin out list, it means every electronics component has pins. We call them something, for integrated circuits, we call them pins. For the discrete components, we call them terminals. So the second part actually teach you about either terminals of the component. For instance, a resistor, it has terminals, two terminals, or it gives you description about the pins if it is integrated circuit. But in dot pins, what do you have? First, assignment. So what is of assignment? How do we assign numbers to the pins? How do we assign numbers to the terminals? For instance, in case of the diode, it has two pins. One is anode, the other one is cathode. Any types of diode, whether it's general purpose diode or special purpose diode, it has two pins. Even the triac diode, which you have learned in power electronics, you drew three terminals, but the two terminals are common. It's cathode, it's anode, and the other one is what? It's anode. That's why we say that a diode is a two-terminal device, or it's a two-terminal semiconductor component. Okay. I'm trying to speak in the electronics engineering language, but I have people who are receiving some other information, because the antennas is actually picking some other signals in this surrounding place. Number 3, the third main part. The third main part that you have to analyze in data sheet or technical data sheet or data sheet of electronics components, it's detailed tables of electrical specification. Electrical specification. Electrical specification. So the second one is called the detailed tables of electrical specification. So, okay, if you like, you can read the second main part, because for me, I like to read it several times in order to click in my mind, because I like, because there is a secret hidden there. Saying pin out list. Then saying pins assignment. Then pins configuration. And then pins description. It means what the function of each pin, what the function of each terminal. That's the point where we learn. But if I'm allowed to edit here, I can also add some information or terminal. Because for the discrete components, they don't have pins, they have terminals. Okay. Then if you wish, and if you like, say detailed tables of electrical specification. Again, say it for the second time. And I usually teach you about the engineering philosophy. That engineering, it's all about numbers. It's all about the formula and equation. It's all about tables. It's all about diagrams. It's all about graphs. And my responsibility in these 2 semesters to prove it. And I've prayed to God to help me to prove it to you. Because you saw that we are making jokes, or we are just making politics in the class. Okay? So you saw even manufacturers' mind, it involves tables. So if you don't like tables, in case you read the data sheet, you see the tables, you will never understand. And tables of what? Electrical specifications of the component. Electrical, detailed tables of electrical specifications of what? Of the electronics component. Why do you need this one? Because that electronics component is going to use electrical energy to operate. Are we together? It's just like what we say that human beings has what? Some common what? We say that common characteristics of the living organism. We learn them in biology. Right? Okay. So the first part Normal recommended operating condition. Operating condition. Normal recommended operating condition of electronics component. Of electronics components. So normal operation, normal recommended operating conditions of electronics components. Say normal recommended operating conditions of electronics components. Okay, can you speak it loudly again? Can you speak it happily? Because you speak it while you are sad. You are very unhappy, according to your face. You see? Say, for me, just speak it powerful and happily. Normal recommended operating conditions of electronics component. Okay, thank you. We'll see who will keep the information, I or you. Just ignore about pronouncing and mentioning. Then, the first main part of any electronics datasheet or datasheets of electronics component, it's called, we call it graphs. We call it what? So ask your neighbor. During semester 1, Olenjolai told you to buy a graph pad. And then you disliked it to draw graphs. And you spend the entire vacation, you have never drawn any graph. Ask your neighbor, is it true? Ask your neighbor, did you draw any graph during vacation of 7 weeks? Listen, his or her answer. In case he or she says that, yes, I drew, then tell my neighbor, bring it to me tomorrow, next Monday. Bring it to me next Monday. Simple. Because you say, I love electronics. I love electronics engineering. I love. Me and electronics, damn. Fine. We agree. By words, damn. Practically, maji. Say graphs of electronics component. Yeah, so electronics engineering is all about graphs. So when I have been introducing this philosophy, possibly some of the students say that this teacher is crazy, has been confused. Mentioning graphs. Graphs is for physics science. Okay. Thank you very much. I was crazy by that time. But for this time, I know. If you're not jealous, you appreciate the information I'm giving you. But if you're jealous, keep your jealous. Say graphs of electronics component. Yes, at least I feel that you are health before you were dead. Then, number 6, we say that truth tables of digital electronics component. We taught you about truth table in digital electronic science. Then you left them. You have been using Boolean laws of simplification. Now you have the module that called the fundamental of digital electronics. You learn those stuff as just like a supplementary material. You don't want to keep and bother yourself. But today we are telling you that the information we are teaching are useful. So if you are reading a data sheet of a digital electronics component, believe me or not, you will find it's truth table. If you don't know how to interpret it, then we'll tell you bye-bye. Ask again your neighbor, do you still love electronics and telecommunication engineering? You see, you don't have confidence to ask your neighbor because If the same question be asked to you, you don't have the answer. If you try, you say, no, you know that I'm in the 90% of the class. Not the 10%, no, 90%. But you should bother yourself. If you don't see vision, electronics and telecommunication engineering, the doors are still open. Just cancel this registration, apply the other course in next offer. It's a good option. Okay. Say truth tables of digital electronics component. The one you have been drawing. The truth table of NOT gate. The truth table of AND gate. The truth table of OR gate. The truth table of NAND gate. The truth table of encoder. The truth table of maybe a particular decoder. The truth table of exclusive OR gate. The truth table of exclusive NOR gate. You will find truth tables, whether you like or don't like. Okay? Okay? In analog, we don't have truth tables. The seventh main part. Say seventh main part. Say seventh main part. So the seventh main part is called the timing diagram. Timing diagram of what? Of digital electronics component. Timing diagram of digital electronics component. Say timing diagram of digital electronics component. Timing diagram of digital electronics component. Yes, we don't have timing diagram for the analog electronics component. So those are the 7 main parts of the data sheet. Refer your notes that you have written for the solution for the homework. Refer if you are those 7 main parts. Refer. Refer. And then once you refer, you can correct yourself. And this is what I told you to go and find. And you told me that, sir, don't worry. Next time, we give you answers. And the next time is now. If I ask you, I will be crying. Hey, student is naughty. Do the homework. No. So these are the 7 main parts. The first one, is what? Summary. Say summary of features and functions of electronics component. The second main part is called what? Pinout listing. Where we discuss about what? Pin assignment, pins or terminals assignment, pins or terminal description, pins or terminals what? Configuration. The second main part, read it. Read it loudly. Your voice has gone down. Okay, detailed tables of electrical specifications of electronics component. The next main part. The fifth part. The sixth part. The seventh part. So before I teach about the first main part, because the other parts I will teach in the next workshop, let me explain in short about what you expect to learn in those 7 main parts. In the summary of features and the function of what? Of electronics component. Actually, every electronics component has its features and has its main function. Or its function. So the manufacturer say that the components I made can do the following list of functions. Are we together? Then in case of the features, the components that I made, the electronics components that I made, has the following features. Number 1, let's say that it has a low forward voltage. Number 2, it has maybe it needs maybe it can operate with low current. Number 3, it can work at the temperature up to 150 degrees centigrade. Number 4, so those are what we call them features, but they don't actually, there's no numbers in case of features. Those are the just the features, the descriptions, what has been built within that component. Are we together? Maybe you can say that these components, it has OT over current protection. These components, it has the OT, or maybe it has minimum power dispersion. So that is the meaning of summary of features and OT and function. Then, in the second part, pin house list, I said every component has either terminals or pins. So for instance, if we have a component, which is this one, so this is integrated circuit. So we have pin number 1, pin number 2, pin number 3, pin number 3, pin number 4, pin number 5, pin number 6, pin number 7, pin number what? Yes, pin number 8. This is the simple operation amplifier, because most of operation amplifiers, they have 4 pins. Students, I say stop writing, stop chatting, stop looking down, look on the blackboard. You have written those 7 main parts. Listen, I'm giving a brief description. So, the features, the first part will give you the features of this component and give you the function, what it can do. What it can do. Then in pin list, in this one, because this is the notch, you'll see that. This is pin number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. That's the pin list. Because we used to number in anti-clockwise direction. We talked about clockwise moment and anti-clockwise moment in the topic called equilibrium, Form 2 physics. And hence, what the principle of moment? The total clockwise moment should be equal to the total anti-clockwise. You forgot. Wonderful. Come back to the data sheet. Okay. So it means that pin list, we have already listed. But remember that these pins are not numbered within. These pins are numbered here. 1, 2, 3, 4, 5, 6, 7, 8. Are we together? I'm giving you brief descriptions in order for you to know where are we heading to. So you can decide either to join the next workshop or to ignore it. It will be fine. Then, when you say that these are the pins, they are not terminals. Then, when you say pin assignments, what you have done is all about assignment. But pin configurations, sometimes you call it pin configurations or pins or terminal assignment. Right? Then pins description. In this part, the manufacturer will explain, pin number 1 does this. Pin number 2 does this. Pin number 3 does this. Okay? Okay? And then, in that one, when you say pin assignments or pin configuration, you can see that. Let's say pin number 1 is a VCC. Pin number 5, it's a ground. So you'll see the labelings and the naming of the pins. Pin number 2, let's say it is inverter 1 or inverting terminal. Pin number 2, pin number 3, it is non-inverting terminal. Non-inverting OT terminal. Pin number this one, it's positive power supply. That's what will be here in this part. Are we together? Are we together? Then, detailed tables of electrical, say detailed tables of electrical specifications of electronics component. This part will tell you that, first of all, what is operating voltage? Operating voltage for this component. Because I told you that in electronics, the one important and fundamental block is power supply. Okay? And then this part tell you about what the maximum current can these pins provide when they'll be used as a input, as output. And then in that part, give you a description. What is maximum current that the input pins can receive from the external source? Because if the maximum current has been exceeded from the external source, then you are going to burn out. Then you are going to burn OT to burn out the electronics component. Are we together? Class, are we together? So that's the meanings of electrical specification. Then, number 4, say normal recommended operating conditions of electronics component. What do you expect it to see here? First of all, most electronics components are very sensitive with the rise or fall of temperature. So in this part, the manufacturer will tell you that these integrated circuits can operate from this range of temperature or from this minimum temperature to the maximum temperature. If you want to use it effectively, then you have to make sure that you do what? You bear that condition. If you exceed or if you deviate, you'll enjoy it. Are we together? It's just like you. For instance, now, if we take you and put the place where the temperature of 100, can you operate there? Can you be in the class where the temperature rose up to 100 degrees centigrade? No. You know 100 degrees centigrade is the boiling point of what? Of water. So can we place you into boiling water? And hence you are taking a class of 2 hours? Can you? No, unless you are dead. So similarly for the electronics components. Then we say graphs of electronics components. Say graphs of electronics components. Mostly data sheet. I think, according to my research, I think that one of the documents or technical documents that has a number of graphs, it's data sheet. You may find a data sheet which has 10 graphs of the one component. 10 graphs. For you, you had a vacation of 7 weeks. You didn't do even one graph. Also, you had a semester. This is the 4th week. So you had 11 weeks as the electronics and telecommunication engineer who is in true love. You have never drawn the graph. So ask your neighbor, are we really serious? Ask your neighbor, are we really serious with this business? Okay. Fine. The response I know. Then we come for the truth tables. Say truth tables of digital electronics component. Most of analogy, most of digital IC or digital components, we have to draw also, it's a truth table. So the manufacturer might draw. And don't think that the truth table which has been drawn by, let's say, by these technical sheets, that maybe it's the one that maybe you are familiar with. And so you say that, these truth tables are very simple. Let's say this is A, this is input B, this is output. You say that 0, 0, 0, 1, 1, 1, let's say 1, 0. Okay? Or even just at this point. Okay, maybe you expected the truth table of AND gate. 0, 0, 1, 0. So you expected the simple truth tables like that. No. You will see truth tables which have X instead of 0. You will see truth tables which have some short abbreviation. So don't think that it's just a truth table of... If it's a truth table of AND gate, yes, you will see. And in case it is AND gates of the 2 pins. If it's the AND gates of the 4 pins, you won't see that truth table, you see the other one. Class, are we together? Yes. Are we together? Yes. For instance, let me show you one of the truth tables. Do you see one of the truth table? This is the one of the truth table. Just you see this one on top. This is the one of the truth table. And it's a truth table of just a simple electronics component, which is shift register. Do you see? Do you see? This is the truth table I took from data sheet. This one is a truth table I took from the data sheet. Do you see? Yes. Just check it. Does it look like 0, 1, Do you see 0, 1, What do you see? You see X, 1, 1. That X has a meaning. Do you see? Okay, keep enjoying life, In college or in university level, we say, endelea kula bata. Tell your neighbor, endelea kula bata. Tell your neighbor, endelea kula bata. Labumu, endelea kula bata labumu. Au hela mzazi. Endelea kula bata tu. Nasi naendelea kula bata. Okay. So, that is the truth tables of... So I showed you one. this one. This is a simplest truth table. I don't want to tell you that this is stuff are difficult. No, I just want to tell you that be serious. As long as you say that electronics and telecommunication engineering is your passion, be serious. Otherwise, leave it. Okay? Are we together? Are we together? Then number 7, we call it timing diagram. Say timing diagram. Timing diagrams is actual tell us of digital signals. For instance, we just know that we have 0, 1. For instance, I can draw the timing diagram for this truth table, which is AND gate. Would you like me to show you some secret? Yes. The timing graph for this truth table, it's low, 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 low. This is timing graph for A. Then the timing graph for A, it's still low, but B, it's high. Then out, it's low. Then the timing graph for this combination, we say that it's what? It's high. So it's high, and then it's still high. The timing graph for this combination, it's what? Wow. It's high, low. So this is A. So this is AB. Remember that this is AB. So we can have something we call this one. So I think that I made a mistake. Then this is 0. This is 0. This is 1. This is 1. Then also we have another timing graph here. So this is for A, input A. This is for input B. So this is 0 bit. This is 1. This is what? 1. And then here it is 0. Then we have what? 0. Then we have what? 0, 1, 0. Then what's going on? So we say that the timing graph, there is a time taken for this AND gate to switch its state from high to low, which is we call it T1. Then also there's a timing for this AND gate to switch from high to low, which we call T2. Also there's a timing graph for that AND gate to switch, let's say from what? From low to high, which you call T time 3. So I don't want to tell you what do T1, T2, T3 represent. So you see your friend? Do you see your neighbor? Do you see your neighbor? Those are the bongos. He's chatting. While I'm teaching there about timing graph or timing diagram, he's what? Those are the students that have been given physically. Good. Congratulations. Keep it up. Okay, so this is the simple example of timing graph. But you could say that, oh, Olenjolai, you are complicating. Thank you very much. Let me show you one of the timing graph from one of the data sheet. This is the timing graph. This one. This is a timing graph for integrated circuits that we call this one is what? Figure 4 what? Right. Okay, timing graph. Yes, for one of the digital electronics components. This one. This is the timing graph. This is the truth table. Okay? So this side they didn't see, they haven't seen. This is the timing diagram. So you say timing diagram is something like this. And it is not complicated, it's your level. You have understanding and knowledge and intelligence to understand more than what has been written here. It's just a matter of yourself to use it effectively or to abuse it. Do you see the timing diagram? Do you see the timing diagram? This is the timing diagram. One of the examples of timing what? Diagram. One of the examples of timing what? Diagram. Class, are we together? Are we together? Yeah, so don't think that because we mentioned 7, you think that they are very simple. We gave you a warning. It's not easy to understand. It's not easy to understand, to read and understand. So let me end this session by just explaining the first part. Then I will end the class. Because if I've mentioned, then you say, even our teachers just mentioned. He didn't give us detail. No. I have to give you detail. Then for the case of graph. Number 7 is graph, eh? Where are the graph? Number 5, eh? These are the example of the graphs. You see? Example of the graphs of one electronics components. I took them from the data sheet. Where they come from, that's why you came to learn electronics and telecommunication engineering for 4 years. These are some 4 graphs of one electronics component. Do you see them? Do you see them? I am not the one who drew it. It has been drawn by manufacturer of this electronics component. And it is simple discrete component. Simple integrated component. Do you see the graphs? They look like the one you drew in advanced science, in advanced physics. They look like, okay, good. So, spend 11 weeks of your life in electronics without drawing any graph. And then you will understand this by miracles, right? You just sleep, you wake up, you can interpret them. Are we together? Are we together? Are we together? Yeah, so the first part is just short. I will spend almost 10 minutes to wind up. So let me explain the first part. Then in the next workshop 3, I will teach you the second part up to the 7th part. And then after that, I will give you, or you'll find a number of data sheets. Try to read them. I want to tell you that you will understand more than what you have been thinking. So number 1, the first part. Summary of features and the functions. Features and function. Summary of features and function of electronics components. So what do we have to know in this first part? Here it's a description. The first page of the data sheet. The first page of the data sheet. Say first page. Again, say first page. It's just like it. The first day that you were born. Do you remember your birthday? Can you tell your neighbor? If you like a family life, we can celebrate birthday in each month. Yeah, for me it's fine. It's a part of life. But if you say, that's my privacy, okay, fine, keep it. Because for my birthday, for me, it's just in August. 1st August. You will be in vacation. And I know once you will be in vacation, Olenjolai, bye. Sasa, saya kwenda kwetu. Kwa heri mwalimu tunaenda likizo, bye, utajijua mwenyewe. Say the first page. Yes, I know you. The first page of the data sheet is usual. Is usually a summary of the functions, and features. Of electronics component. Let me clean the other sides of the blackboard quickly. This is where you can quickly find. This is where you can quickly find a description of electronics component. The descriptions of electronics components. Electronics components. Functionality. Functionality. The basic specification. The basic specification, which means numbers that describe what a component needs and they can do. It also, this first part, describes, sometimes describe, it also describes functional block diagram. Functional block diagram that shows the internal functions. The internal functions of electronics components. Of electronics component. This page will give you a good impression or a good first impression. First impression whether a component will work for your project or not. So this is descriptions about the first part. Stop writing, listen and watch. This is brief descriptions about the first part, which is called the summary of features and functions of electronics component. So summary of features and the functions of electronics components. So listen, I say stop writing, listen and watch. The first page of any data sheet, because we say summary, and this is introductory, we say it is introductory page. The first page of the data sheet is usual a summary of function and what? A summary of function and what? A summary of functions and what? Yeah, the first page of most electronics. Whether that electronics components has 50 pages or 40 pages or 1 page or 2 pages or 3 pages or 10 pages. The first page will give you a summary of functions and features of electronics components. Are we together? Then, the second point. This is where you can quickly find, what is a description of electronics components functionality, a description of the basic specifications, numbers that describes what the components needs and can do. That is what you can find quickly. So in the first page, you expected to see or to learn descriptions of the functionality of the electronics component. Say functionality of electronics component. In the first page. But also in the first page, you can also see the basic specifications. Which means the basic specification of the components. For instance, we say in bracket, numbers that describes what the components needs and they can do. So numbers, it means that it's kinds of the pin assignments. In the first page, you can see also something called pin out or pin out list. Right? Are we together? Then we say that it also describes the functionality. Describes the functionality. Say functional. Describe the functional block diagram. Say functional block diagram. In the first semester, I taught you more than 3 workshops, and I think that I taught you more than 5 workshops, or I think that all the workshops I've taught you, we have been mentioned about block diagram. Right? And possibly you will notice that this teacher is crazy. He just knows nothing rather than block diagram. And I would like to say, thank you, I was crazy. But I was not crazy. Right? Right? Because what I was telling you is technically acceptable. So you can find, say functional block diagram. I taught you about the general block diagram. I taught you about the detailed block diagram. But I haven't taught you about functional block diagram. But for you, as
Africa.